through our education system, and then tell you a little bit more narrowly focused information about the program at the University of Moratuwa in the Department of Computer Science and Engineering. So to start off, as you know, um, in our country, we have this formal education structure. Um, so we have the primary education, grade 1 to 5, and then the secondary education, grade 6 to 13, and then the tertiary education, uh, um, as now, of course, I education and so for personal interest, you information technology. Right. Sorry about that. I changed my network connection again. Silas, can you hear me? All right. Yeah. So as I was saying, to be really good in AI, there are some basic, foundation level knowledge that you need. They come from the primary education, the basic literacy, numeracy, critical thinking, and the ability to learn and study and observe those skills. Yeah. So all of that you already have. And then in the secondary education, you need some more of these skills in languages, in mathematics, in social studies, to really understand the intelligence, because before we can go into artificial intelligence, we need to be able to differentiate between data, information, and knowledge. So data is basic, pieces of information that are not really connected. Uh, and then information is when you process this data. So if you take a page of text, so we can say as data the words that are there. So if you look at my slide, there are words there, formal, structure of education, like that. So they are just data. And even the whole sentence, like formal structure of education, that you can say as data. But it becomes information when you process this. For example, when you look at this and you understand, I'm trying to tell you about the structure of education, which has basically three parts uh, as a framework. So that now you go from data to information, and then comes the knowledge. So knowledge is not on this slide. Knowledge is when you really look at it and understand, okay, I have these skills from the primary school. Then I have this knowledge from the middle school. And then now I am learning about these things in the upper middle school. So that way you have some knowledge being developed. So uh, the specialization uh, to be an expert in the area of AI, you will get this opportunity at the tertiary education level. So there are basically two main um, what we call focus or streams or thrust areas in tertiary education. One is vocational, other one is professional. So generally, the professional education comes from universities, and the vocational comes from training institutes like that. So generally, when it is vocational, you can have different levels, different kind of achievement. Maybe you can do a 6 months course and get a certificate, 12-month or 1 year course and get a diploma, or 2 year course and get an advanced diploma, or what you call a higher diploma. Um, and generally in the universities, no, you should do at least a 3 year study program and get a degree, or a 4 year study program and get a 4 year degree, which is called an honors degree. So those are the places where you can get further specialization. Okay. And sometimes no, you might do a degree in, say, uh, commerce area. So you have a degree in economics, but then you go and do a 1 year diploma in AI for business management. So that way you can get a specialization in the area of AI, what we call a domain area in business management. Okay, so um, anyway, I will stick to my area of specializations. Let's move to the next slide. As you know, we have in our education system now, earlier it should be 4 streams. Now there are 6 streams: the arts, commerce, biology, or bio, physical science. Uh, then we have the engineering technology and the biosystems technology. Of course, our college has arts, commerce, bio, and physics, physical science, or what we call the math stream. Um, and then within each stream, we can have a set of what we call fields of study. This is relevant because based on the type of uh, type of stream you are going to follow, which happens after the O level, when you enter the A level, you will get different type of fields of study made available to you. So I have highlighted physical science because that is what I did, and that is where my expertise is. And then when you do physical science stream, you can move on to these different fields of study. Um, right. Um, so in the uh, physical science stream, we have several areas like engineering. These are the main areas: engineering, or physical science, or computer science, or applied sciences, like that. Within each of these fields of study, you can have another subset of specializations. Now, we are talking about AI. You can uh, bulk of AI education happens in the physical science stream. And then you can have it to a very lesser degree in commerce stream also. But mostly biological sciences Sorry about that. So we are going to have network breakages now and then. And uh, Silas, can you hear me again? Okay, right. Um, so as I was saying, much of the opportunities to learn AI is in the physical science stream. Um, Very little in commerce or engineering technology, and nearly not much opportunities in biological sciences, biosystem technology, or arts. But you can use AI a lot in the fields of interest or set of fields that are in the arts. But learning it is mainly happens in the physical science stream. Um, but I know a lot of people who have done studies in biological sciences or who are in the bioscience classes and later became real experts in the AI area, especially because AI and machine learning, artificial intelligence and machine learning is used heavily in the areas of medical sciences, pharmaceutical sciences, drug discovery, um, and genetic sciences. So like that. When I say that, much of the opportunity to learn AI is in the physical science, I mean at at a starting point. Late, I mean, you can become a doctor and later become an expert in the area of AI and machine learning in that domain. So don't think that if you want to learn AI, only way to do that is to do physical science. No, I mean you can become a lawyer. Okay, so that would require you to do, for example, either the commerce stream or the art stream. Um, if you look at our country, the three top people in the government legal profession, the Attorney General, and the other two, the top three people are all royalists, all from my batch in the college, and they have all been in the same class, uh, Commerce 12B, 11 and 12B, and yeah, so that's how they are in the legal field. Um, uh, and no, so you can become a lawyer and then become an expert in the area of AI as applicable to the legal profession. Okay, so I think it's very important that you follow a stream of study that really interests you. And if you have interest in AI, only mainly in AI, then most likely physical science is a better fit for you. But if you have a lot of other interests, say you are interested in becoming a lawyer or to follow bioscience or become a business expert in the business area, so you can follow that and still be an expert in AI because at a later stage there are opportunities to gain a lot of knowledge and expertise in those areas. But I'll stick to physical science as highlighted here because that is what I know. Okay. So in the physical science stream, there are these fields of study like engineering and then the physical science, computer science, like that. Um, and all of these areas have different courses of study that provide you with opportunity to learn about AI. Um, and each field of study, like for example, engineering, there are sets of sub-specializations or fields of specialization. So as highlighted here, my area is engineering. So let me talk a little bit about that. So um, in our country, we have these area of specialization like civil engineering. So these are the traditional areas of engineering. Civil engineering is one area, um, and And then electrical engineering is another traditional area. Yeah, civil engineering, electrical engineering, mechanical engineering. So these are called the traditional areas of engineering. And then later, other areas of engineering got developed, for example, chemical engineering, um, and materials engineering, um, and electronics engineering, uh, and yeah, earth resource engineering, mining and mineral, like that, and much more, like maybe so. In Sri Lanka, the computer engineering field is about 50 years old, like that. So we have computer engineering, um, mechatronics engineering, textile engineering, like that. And more recently, maybe about 20 years back, we had, or 15 years back, we have the fields like biomedical engineering coming up. So, and even more recently, transport and logistics engineering. So, uh, if you look at these engineering fields, AI has become relevant to every field of engineering. But if you want to learn about AI and become an AI expert, then the areas like computer engineering or computer science and engineering, these are the areas where you can get that expertise mainly. Okay, so as highlighted here, I'm from computer science and engineering. So I'll be talking a little bit more about that. So we had this, um, as I said in the previous this slide, there are fields of study. So engineering is a field of study, and within engineering, there are specializations like computer science and engineering, which is a specialization, and then within that you have different sub-specializations. So little bit of um, advice here. Uh, the list of specializations that I have shown you here are the state universities, okay, the government universities. And as you know, we have private universities, so they have nearly the same kind of specializations, and maybe there are little bit more different ones. For example, we don't have automobile engineering in the state universities. That there is a private university with automobile engineering. Okay, as example. So you should look at that also. So as I said, so caveat emptor means no, you should not believe everything I say. No, check what I say also. Okay, right? Yeah. But I try to give you as accurate information as possible. Right. Okay. So now because we are focusing on AI, so if you are interested in no engineering field, basically computer engineering, and then want to study AI in the computer engineering field, there are many universities in the country that have these programs. University of Peradeniya, right now it is underwater. They have computer engineering department with a very good program, and then of course University of Moratuwa, we have the computer science and engineering department. It's highlighted because I am from there. Okay, and then University of Ruhuna in Galle. We have a computer engineering program there, and University of Jaffna. All this University of Jaffna, the engineering faculty is in Kilinochchi. It's a very nice place, very large place. They have a computer engineering program, and then University of Sri Jawaharlal. Although it is Sri Jawaharlal, this is in Mattegoda of Kottava, the Faculty of Engineering, and they have computer engineering. Okay. So there are, yeah, okay, opportunities available to study AI as a computer engineer. Okay. So let's move on to a little bit more about the University of Morato program, because that is where I have knowledge. Okay. But before that, you may want to study AI not as a computer engineer, but as a computer science specialist. Okay. So now, if you look at the state universities, there are five currently offering the computer engineering program. If you are interested in studying AI. Now, if you want to study AI in the computer science field, actually there are more programs. So we have just next to our college, we have the University of Colombo. In fact, when you go to the grounds, you can see the School of Computer Science, University of Colombo School of Computing. Uh, on the our scoreboard side, right? And then you have the University of Caledonia, University of Jaffna, University of Edinburgh, University of Runa, University of Vaunia, like and Rajarata University of Sri Lanka and Sabaragam University, Uvelas University. All of these universities have some program where you can learn some AI. Okay, what I have listed here, the five universities here have somewhat matured or matured programs in computer science that have AI. Okay, so let's look at in bit more detail at where I come from the Department of Computer Science and Engineering, University of Moratuwa. So our department has three sub-specializations apart from the main specialization. So as I told you, the field of study is engineering, specialization is computer science and engineering. The sub-specializations, there are 3+1. So plus one means the mainstream, which is the computer science and engineering. Everybody becomes a computer science and engineering no specialist. But then you can also have what are called streams or sub specializations. So there are three of them. One is integrated computer engineering, which focus on embedded computing like robotics, drones, IoT, smart vehicles, smart transportation, like that. Okay. And then we have data science and engineering, which is basically focusing on AI. And then cybersecurity. As you know, this is a major area of interest now. Computer security, network security, software security. So all of that are part of the cybersecurity stream. I have highlighted integrated computer engineering because that is where I am in charge of. But of course, I know about the other streams also, right? Um, so, um, one thing as students you might encounter is these different terms: computer engineering, computer science, software engineering, information technology. Are they different? Are they same? Of course, they are not same, right? Then there won't be different names, no. But how different are they? Or how similar are they? Now, if you look at the main ideas behind these different areas, computer science is more about design. So if you are going to um, develop for example, let's say we are going to develop a artificial intelligence based um, system to give medical advice. Okay, so now you when you want to suppose you don't feel well, so you go to see a doctor, right? And you will explain various issues you have, the symptoms you have, previous medical conditions you had, any medication you have had previously or currently you are taking, like that. No, you give a lot of information to the doctor, and then the doctor will analyze that, will ask you some questions, will ask to do some tests, and then we'll look at those test results, and then will give you a diagnostic saying, okay, it looks like this seems to be a problem, and then give you a prescription of medicine and advice, right? So suppose we want to have a AI system do this. Now, there is the need to design such a system, and you have to look at the theory behind developing such a system. So, computer science is mostly focused on that area. And then once you have this design, you have to build it. So, to basically develop a software. So software engineering is where you do this building. And then once you have such a system, you have to operate this. So you should be able to, for example, it might be a online doctor. So you go to a website and then click AI doctor, and then some chatbot appears, and you start discussing, and then it asks you to do some test and upload the test reports. So you go to some medical laboratory, get the test done. They send you a report as a PDF file, and then you upload it like so. So this happens through an interface, but that interface is connecting you to some server, a web server, a database server, an application server, like that. So these systems have to be operated. So the information technology is about operating such systems. So when you take my area, computer engineering, it actually covers all of these areas uh, to build solutions. So design, build, and operate solutions. Um, so um, that's how the different sub areas contribute to building solutions. So you can specialize in AI in any of these areas. So you can be a software engineer in AI, you can be a IT professionals in AI, you can be a computer scientist in AI, or you can be a computer engineer in AI. So depending on that focus, you can be engaged in different kind of work. Okay, so now let me just give you some insight as to uh, what you will learn or what you have to learn if you are going to follow a university degree program that focus on AI. Okay, so I'm going to just show you what we do at University of Moratuwa in the Department of Computer Science and Engineering. So this is just one program. If you look at other universities, other programs, there will be differences, but you can take this as a like a model. Okay, but don't think that this is the only way in you can learn about AI, or that this is no, one particular way, right? Okay. Um, Silas, can you see a spreadsheet now on the screen? All right. Okay. So this is what we teach. So we have a 4-year study program. So, for example, now in the college, you learn for 2 years in the ordinary level classes and 2 years in the um, advanced level classes. And if you come to the university, say our university, you will learn for degree program. So in our university, the 4 years is broken into 8 semesters. So semester one is common to everybody, where you get what is called the engineering principles. Okay, so you will again learn mathematics with higher mathematics, and then you will learn programming fundamentals. Here, basically, the focus is on Python programming as well as data structures and things like that. And then you have other engineering modules, mechanics, properties of material, fluid mechanics, electrical fundamentals, like that. Okay, and of course you get a course in English language also. So that is the first semester. Second semester, you will go into different specializations like electrical engineering, mechanical engineering, chemical and process engineering. So if you come to our specialization, which is computer science and engineering, as shown here, um, right? Uh, okay. So yeah, so this is computer science engineering. Yeah. Uh, These are the modules in the semester two. So again, still, this is about computer science and engineering, where you learn about data structures and algorithms, program construction, computer organization, and digital design. So these are a bit more. These about actually the design parts. Um, as I said about earlier, so you have the design, you have the operation, you have the development. Okay, so this program concept about more like programming, developing software, and then this is more about hardware. Then we have the semester three, and of course you again learn mathematics. Okay, it's very important. Mathematics is very important, especially if you are going to AI, become expert in AI. When it is required for engineering, and there are other subjects like theory of electricity. Then semester three, uh, you learn again a lot of mathematics, differential equations, and applied statistics. So for area of AI, statistics, probability and statistics is very important. So applied statistics covers those areas. Okay, and then there's are uh, um, other subjects um, in computer science and engineering, data communication, operating systems, computer architecture, database systems, like that. And this is the first course where you get introduced into AI, introduction to AI. Okay, so that happens in the second year. Semester three is the first half of the second year. Okay, right? So you get an introduction to AI. So I'm just trying to give you an idea like what you will learn if you go into the field of AI and try to get a degree qualification, a professional qualification in that area. Okay. But this, as I said earlier, so this is just one example of a program which is offered by us. Um, and then this is the second half of the second year, where again you learn a lot of mathematics, linear algebra, graph theory, like that, and then software engineering. And then you have more AI related courses. For example, introduction to machine learning. So previous semester you learned about introduction to AI, and this semester you learn about introduction to machine learning. And before learning machine learning, you get a course in applied um, here applied statistics, where it covers statistics, probability, and statistics. Okay, because that is required for machine learning, and also you get introduction to what is called data science. Okay, so the AI, machine learning, data science come together when you are learning to become an expert in the area of artificial intelligence. And of course, there are other courses which are offered because this is an engineering program like IoT and other programs. Okay, so this is the second half. Sorry, this is the first part of the third year. Okay, first part of the third year. Now you get to learn more advanced material in the AI area. For example, deep neural networks. Okay, so when you learn about AI, earlier there was a course introduction to AI. you learn about what is called neural networks. Okay, the area of AI will teach you that uh, the way we want to solve problems is not through a what we call a deterministic process. So when you learn about programming in college, you learn to create a algorithm, right? Algorithm. So whenever you want to complete some task, you develop an algorithm giving step by step instructions. Do this, next do this, next do this, like that sequence, and then you may repeat that sequence in a loop, or you might take a decision. If this condition, then do this, else do this, like that. So these are the sequence, repetition, and decision type actions you take in developing an algorithm. But when we move from that kind of what we call the deterministic way of solving problems to the AI area, it becomes probabilistic. So in that, the way we develop solutions is to look at uh, things and say, okay, the likelihood or the probability of something happening is this, and based on that, we start taking decisions. Okay, so that is the basic idea of a neural network, and then the advanced versions of this area is deep neural networks. So you learn about that. And then in the data science area, so I told you there are three different kind of strands. So see different um, sets of knowledge that we are working on: AI, machine learning, and data science. Um, so then we have the AI area continuing with deep neural networks, and of course it has some aspects of machine learning, and data mining continuing with data science and uh, machine learning. Okay, and then of course there is we get the students to do a big project, individual project, to see how well they have learned these things. Um, and then um we have some other modules in the second half of the third year. You go for training, and no, final year, where you get really the expertise in AI and machine learning. So we offer courses like the advanced machine learning, um, and uh, advanced data structures. But if you look at the machine learning area, the the core modules in that area are the advanced machine learning and natural language processing and bioinformatics. Okay, so you can take these modules in first half or the second half of the course. Um, so this is a sample of uh, courses that you will follow when you are learning to become a engineer specializing in AI. Along with this, what I just explained about AI, you are also learning a lot of software engineering modules also. Basically, software engineering theory here, and then you will learn about uh, human computer interaction, what we call HCI, where you learn how to build interfaces to software systems, and the visualization of data, and a lot of other software engineering modules in software process management, quality engineering, things like that. Okay, and also advanced algorithms, parallel and concurrent programming. So all of these are required if you are to become an expert in the area of AI. Um, so Uh, as you can see, there is no single course called uh, AI or machine learning or data science. So the to learn about AI, um, you have to uh, cover many of these specific modules to gain the required expertise. So I think I'm up on my 40 minutes. Sailesh, hello. Sailesh, can you hear me? Yeah. So I think my 40 minutes is up. We can take questions if the students have any um, questions to ask. You can either put the questions in the chat or you can just unmute and ask. Okay. Okay. The question is, which field has the most demand in the job market? Okay. Right. Um, okay. So a very good question. Okay. But difficult one to answer also because job market is very dynamic or what you call fluid. So, so let me just give you some interesting bits of information. So I did my A level long time ago in 1985. Okay, and in that time, uh, what we call the accelerated Mahavali development project was going on, building these major reservoirs like Victoria, Randenigala, like that. Okay, Morgakand that came later. So and no, the Mahavali project was going on. So there was a lot of demand for civil engineers and electrical engineers because a lot of civil engineering construction was happening. The reservoirs, tunnels, canals, bridges, roads, buildings. So there's a huge demand for civil engineers and also power stations, power distribution lines, transmission lines, switching yards. Like so, there's a huge demand for electrical engineers. Also, because of this development, there was a lot of factories coming up. There was a lot of demand for mechanical engineers. So when we went to the university, there was really no demand for computer engineers. So uh, when we graduated, there were some jobs because there was only few of us. No, we didn't have any problem in the job market. Few jobs, but few engineers also. If you take the other fields at that time, civil engineering, mechanical engineering, electrical engineering, a lot of jobs, lot of engineers, but not enough engineers. There were a lot of jobs that could not be filled because there were not enough engineers. But if you just no, then that was 1985, 90. If you take like year 2000, there was huge demand for software engineers and computer engineers because the IT industry has grown rapidly and there were a lot of jobs for uh, the computer engineers and software engineers and IT professionals, but not enough people. And by that time, the Mahavali development has kind of come to a not to an end, but a lot of the things have been done. So there was less demand for civil engineers and no electrical engineers like that for that kind of projects. But at that time there was a big boom in housing development. Lot of housing construction was happening. So there was a lot of and also road construction. So there was a lot of jobs in civil engineers. And then if you come to like 2015, like that, classes and 2 years in the um, advanced level classes. And if you come to the university, class classes and 2 years in the um, advanced level classes. And if you come to the university, say our university, you will. Silas, can you hear me again? What was the last thing that you heard me say? Uh, no, can you be a little bit more? Can anyone be a little bit more? Because I don't know at which point the connection dropped. Can somebody tell the last thing you heard what I said, like a sentence or like?
It was something about universities.
Right. Okay. Right. Okay. Okay. Yeah. Right. Um, so you're discussing about the housing development, and then all right. Okay. Okay. Thank you, Aftab. That's right. That's right. Okay. Right. Very good. Okay. Aftab gave me a correct answer. Okay. Right. So, okay. I was telling about
Class.
2015, where there were still some jobs. And now I want to talk about 2025, right? Okay. So, if you look at the current situation, there are jobs in field of electrical engineering, but that is for not the traditional electrical engineers, okay, who were building switching yards, doing transmission lines, things like that, or power plants that run on heavy fuel. It is for electrical engineers who can work in renewable energy, wind generators, in battery storage, in solar power plants, things like that. And if you take civil engineering, it is not about the traditional road building. It is about building expressways, which are elevated, which have different designs. And also, when you take about construction, there are various kind of specialized buildings that are coming up. I'm going to tell you, because the question was about the what fields are good in the job market. So it varies. Okay. So right now, if you look at computer engineering, our field, software engineering field has a issue in that if you want to become a software engineer, you must also be very good in using AI tools. Without being thorough with and having good expertise in AI tools, you will not be considered a good software engineer. Earlier, if you are a good coder, then you are considered a good software engineer. But right now, if you are a software engineer who know how to use AI-based software engineering tools, then you have to consider good software engineer. So earlier, when you write software, when you write programs, you have to test the software to see whether there are any bugs in that, and it will be done by another engineer who is called a QA, or quality assurance engineer. But nowadays, the way it happens is when you develop software, you develop it with a assistant, an AI assistant. So, for example, Microsoft provide this Copilot. Okay, like that, there are a lot of these AI tools that work side by side with you. So you start uh, your work on a piece of software, a development environment, and as you work, this AI agent is working with you. So it will give you various hints, various suggestions, and if you make a mistake, it will point out that there is an issue here, like that. So some work which may have taken you like 100 hours, now you can do in 25 hours. Okay. So that is like something that took you like 4 months to do earlier, now you can do in 1 month. And when you can work uh, efficiently like that, the companies want a person like that. Okay, so so to answer the question, so still computer engineering field is in demand because lot of the solutions being developed, a lot of the new products being developed, a lot of the new services being made available are based on computer engineering, software engineering, information technology. So there's a lot of demand for that field. But again, it is important to remember it. The demand is not for the earlier type of IT professional, earlier type of software engineer, or the earlier type of computer engineer. It is for a new type of person who knows how to use these AI tools. Same thing happen in other fields also. For example, if you are interested in mechanical engineering, you must be able to use some of these computer-based tools. For example, if you are into automobile engineering, new vehicles, all of them have a onboard computer, which you can communicate with using a handheld device or connect to a network, and it will give you a lot of diagnostics. And then these diagnostics, that means no all the details, all the data that is collected on the performance of the vehicle, and then this data will be fed into a AI system. So if a customer comes to your company saying, my vehicle needs to be checked, I feel a difference, then earlier you will ask the person who, and you want to speak to the person who is driving it, not real the owner. If the owner is driving, okay, so you will speak to the person driving the vehicle and ask, what is the difference you felt, and try to get all this information. And it's very hard actually, people may not really be able to communicate what they have felt, and you have a hard time finding. Say the person might say, I feel a difference in steering, or I feel a difference in the noises, like that. Okay, but now the vehicle has an onboard computer which collects a lot of data. So you can download it. Earlier, you will download it and you have to go through it and find out various data, analyze it and do it. But now you will feed it into an AI agent, and AI agent will give you suggestions. Go and look at this particular part. Go and make these changes and test this part, like that. So if you are a mechanical engineer or automobile engineer with the knowledge to use that kind of tools, you are in very good position. Especially if you are a auto